All right, I think we're going. So thanks everyone for sticking around today. There's a rule about all trade shows where they're one day too long. So thanks for sticking around till day 3. For anyone in the audience who is expecting Michael Ducey today, sorry about that. I was the speaker who was the backup, and learned this morning that I'm going to be coming to Jenkins World to give a talk. So hopefully we'll be able to cover a lot today about implementing container security across your delivery pipeline. I work at Sysdig. I've been in the customer success and product organizations, and I've really spent the last 3 years helping customers adopt containers, and through security and monitoring, how did they actually be successful with the day 2 operations of, OK, hey, I've stood up this Kubernetes cluster. What do I do now? So starting off, we're just going to go through some of the basics of continuous integration and why it's a little bit different in the container world. So like your normal process, you're going to have a developer who's going to push some code to a code repository. That could be GitHub, GitLab, whatever you're using there. Hopefully you have some automated step that's going to pull that into your build pipeline. And hopefully you're using some of the nice multi-stage build things that you can get from your Docker containers. So you have an image that you're using that has all the different packages and tools needed to build containers. And then you have another image for your runtime environment that then has less dependencies and everything else there. And then once that build executes, that's going to be pushed to your Docker registry. So moving on from continuous integration to continuous delivery, after that build process, you're going to have your testing. It's going to get pushed to staging. And then if it passes all the different security checks, you'll choose to either manually push that, and that's your continuous delivery. And then if you have automated scripts, you're moving out to a continuous deployment type workflow. So a little bit of a difference whether you have that red button or it's automated. But the main difference here comes in when you have an orchestrator. So before, you might just push something out to a VM, but now that image could be scheduled across multiple different nodes, different regions, different clusters. And that's where you're going to use different tools like Helm or Draft to make sure that that image is going to the places that it needs to go. So I actually just pulled this off of the Google documentation, but what this deployment pipeline will look like in a Kubernetes perspective is you have your developers that are committing code to that code repository. You're actually usually going to have Jenkins running on top of that Kubernetes engine, and then it's going to get pushed to your registry, which then can be used in that dev environment or your prod environment there. And it's the same process, but it's really just sitting on top of that orchestration layer with Kubernetes, because the easiest way to build containers is building it in containers themselves. So starting from a contextual perspective, this is the workflow that pretty much anyone is going to be doing from a container or a Kubernetes perspective. And before we get onto the security side, from a show of hands, who is running containers or Kubernetes in their environment right now? So we got about half the room. And for Kubernetes, is that the same? OK, so about half of the half, so a quarter, have adopted Kubernetes. So let's move on to continuous security. And what we're doing from a security perspective is going to be the same thing that you thought about before. So from an implementation perspective, you're going to want to establish those trust boundaries. Where before, this might have been something that's physical, where you have different nodes that you're using for dev, different nodes that you're using for prod environments. In a Kubernetes perspective, this can be different namespaces. So organizations really live or die by the labels that they're using in their infrastructure. And one of the most common mistakes I see when I go into a customer environment who's new to Kubernetes is everything's running under the default namespace. So you can't really split out these different applications. Writing security controls is harder, and things like that. Also going in and minimizing and hardening your attack surfaces. So by baking security in earlier, by having more process isolation with the container environments, those are things that you can do from a security perspective to really improve your posture there. By reducing scope and access, again, going in and using network security policies or configuring it so users can't exec into your containers, really locking down that environment is important. And then, like any security strategy, you're going to want to have defense in depth. So having multiple tools with different failure points and then backup behind those. And one of the most common things that I see is someone will do some compliance testing or benchmarking and traceability as soon as something's deployed, and they don't continuously run those. So that's something you also need to think about from a security strategy. So moving on to these two conflicting workflows that you see in a lot of organizations, you have your DevOps team that's like, hey, I want to go fast. We're moving to containers. Our developers love it. It's easier for me to deploy. And then you have the security team, and when we get brought in there, they're like, whoa, 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 whoa. We're not doing containers anytime this quarter. We need to put some stopgaps in place. And this is where a lot of organizational processes need to change. So you need to be hooked into your DevOps lifecycle. You build it, you secure it, you run it. And a lot of times we see security organizations going in and establishing the benchmarks that the ops team needs to follow. And then the ops team is usually the one who's now in charge of implementing security. Also, one of the things that you've seen from the DevOps practices is managing alerts as code, managing dashboards as code. And the same thing you're going to want to start to think about from managing your security policy as code as well. So having really rich change controls and automation around the policy that's generated rather than relying on UIs and traditional things like that. And then from a process perspective, you need to make the decisions of, are we going to be more reactive, where if we see some problem, are we going to open up an issue, or are you going to start to fail fast, break the build, and never let that go into your production environments? So depending where you fall on the spectrum, there's a bunch of different things that you can do here. So with containers and security, it's new infrastructure, it's new layers, but the attacks that we're seeing are pretty much the same stuff you saw before. So from an application perspective, you're getting your DDoS, SQL injection, all those type of things. And what you're looking for isn't really that much different. It's not really different that much, but from a implementation perspective, now you're thinking about protecting a logical service rather than some piece of physical infrastructure. So one of the things that you see when people are starting with containers is it's like, cool, I got this pipeline set up, it's going really fast, and then they just skip security as a step altogether. And this is something where you really need to step back and view containers as an opportunity for better security. So you can layer in security checks within your CI/CD tool. You can layer in other security checks within your registry. And then pre-deployment, you can hook in with things like admission controllers to then have security really across this entire lifecycle. So what I'm going to do now is go through a couple of the different steps. So build, where your developers are actually building those images, then moving into how those images are actually being deployed. And then most of this, we're actually going to focus on the runtime side of, OK, now that this container is deployed, how are you actually making sure that this is safe in your infrastructure? So from a build perspective, one of the things that you see all the time when people are starting off with containers is they just pull down any random image from Docker Hub, start building things on top of that. And you're going to want to use some type of trusted base image, or go in and also use a minimal OS. So taking something like Alpine as your base image rather than pulling in like a huge Debian base image. You're going to want to restrict the functionality that's also available to that image. So make sure that it's not running as a privileged container, things like that. and then try to go in and make sure that you're using multi-stage builds. So you can see the different layers of your image, see when different packages were inserted into that image. And so you don't have to go and fix something that's part of that base image, and you can really pinpoint when a specific dependency was added. And then on the privilege side, making sure that users are configured for those images, and then who the effective user is. So if your container's running as root in your infrastructure, you basically have access to the whole host. And so you need to make sure which images you're running, what you know about them, and all that type of stuff before it even ever hits the registry. So from a static image scanning perspective, most often this is implemented at the CI to registry step, so as a check before you push an image to your registry. And this is where you're going to look for any of the known vulnerabilities in your environment. One of the cool things that's really unique to the container space is you can pretty much build a full open source security stack. Where in your traditional environments, you basically have to pay for some type of tool. And there are things like CoreOS Claire, which came out, which is now under Red Hat, Anchor, which is another popular container scanning tool, and then also baked into your registry. So Google has a default container scanner. Quay has their container scanner with Claire. And those are tools that you can use to go in and then find those vulnerabilities. So what this looks like from an architecture perspective, and this is how Anchor has chosen to implement container security and scanning. So you're going to kick off that build in Jenkins. It's going to go into the Anchor analyzer. And the unique thing about the Anchor engine is they're really content-driven. So they're going to store all the files, all the packages, all the contents of that image. And that's completely decoupled from the policy evaluation perspective. So what this means here is you don't need to periodically rescan images in your registry. You have all that raw content that then you can constantly update against the vulnerability feed services. And then if any new vulnerability comes out, that status of that image is automatically updated, and you don't have to go in and trigger a new build or go in and rescan that image. So that evaluation happens against all that content. You get a pass, warn, or fail result, and then that image is either pushed to your registry or that build has failed, and you get notified within Jenkins. So from a developer workflow, like you never have to leave Jenkins, and you get all of that data without having to go to any external tooling. So as part of the build process, what are you actually looking for? So this is where you're going to want to see all the different packages that are installed, if there's vulnerabilities for those, if someone has baked credentials into the image. So this is something where you could have a PIM file or do any regex for different secrets and things like that. If those are baked into the image, that's something that you'll want to fail out of the box, and then you rely on other open source tools or Kubernetes secrets to inject those secrets in at runtime. So now moving on to the shipment perspective, we've built that image. Now we're going to go and do some of those different pre-flight checks before it's actually running in your infrastructure. One of the things that is actually baked into Docker and is becoming more important from a management perspective is your content trust. One of the sad things here, though, is usually this is disabled by default. And so you're really going to want to sign those images to make sure that only known and validated images are the things that you're running in your production environments. From a restriction perspective, you're also going to want to lock down the different registries where you're pushing your images to, and then the different CI/CD tools as well. So one of the nice things about Docker Hub is like anyone can push their images there, but a lot of code is getting pushed to Docker Hub that is never really meant to be public. So having a private registry that either you're using through some cloud service or something that you're running on-prem yourself is really a base standard thing that you need to have implemented. And then there should be rotating access keys, tokens, all that type of stuff for your registry. And then one of the new cool projects that's actually coming out is Grapheus, which serves as a metadata API that then you can call out to at any point in time to see all the artifacts across this process. So there you can say, I want to check if this image has been signed. I want to see the last time it's been scanned. And you can build policy in to make sure that you're only deploying images that meet the standards that your organization sets. OK, so from a runtime perspective, now we're ready to deploy these images. Let's look at the infrastructure and how we're going to need to secure this infrastructure. So you have to secure the underlying host where those containers are running. You have to secure that Docker daemon. And then from a Kubernetes perspective, you're going to have to secure etcd, your API server, a bunch of other different tools. Another really nice thing from an open source perspective here is you have the Docker benchmark, the Kubernetes benchmark, and these are basically compliance tasks that you can run that will look at your containers, your hosts, and Kubernetes to see if you've configured all of those in a secure fashion. Docker benchmark comes with 200+ compliance checks out of the box. So it'll say, like, do you have an AppArmor profile for this container? Does this container have health checks? And those will be something that you can really automate as part of the deployment process. And then you're really going in and checking for not only security, but for compliance and reliability of those containers and those hosts as well. One of the common mistakes here that I see from a CIS perspective is a customer runs it like once a quarter for an audit and then never really does anything with the data. So this is something where just schedule these benchmarks as a cron job or go in and use something like Chef and Spec to go in and have these running on a regular basis. So you're not just going in and doing like what you need for the auditor. You're actually taking actions based on the results from these benchmarks. So now let's move over to a little bit of a Kubernetes-centric view and what you can do with access control within Kubernetes. So talking about some of the different constructs, namespaces are basically the different areas where you can apply these permissions within Kubernetes. And then from a subject perspective, you can tie this to users or different service accounts. And then you can tie these to different pods. You can tie this to a deployment and the different constructs within Kubernetes. And one of the really nice things that's out in 1.12 of Kubernetes is the audit API. So one of the things that's been a huge security flaw and something that's been hard to take into control from an audit perspective is the who did what where within my Kubernetes infrastructure. So because the Kubernetes API is exposed and developers can just kube control exec, get shell access into a container, you don't really have that access control of, OK, this user did this at this point in time. And now that this audit API is exposed, that's something that you can just send out to whatever you're using as a logging tool to have some of that kind of intrusion detection visibility that was previously missing in the Kubernetes space. And then one of the other sections that's kind of in that pre-deployment cycle is admission controllers. So admission controllers will go in and before any image is actually started, give you the ability to define pod security policies. And this is where you can say, this given image should only have access to these volumes. These are the read-write paths that this image should have access to. Here's the default profile that I'd want to apply from an SE Linux perspective, an AppArmor, a SecComp. And this is where you can really bake in a lot of this security before you even get into that production environment. On the flip side, one of the main things that I see customers running into here is this is enforce only. So you kind of have to write this policy, cross your fingers, and hope you don't break someone's application. So something you definitely want to test before going in and deploying this across your whole cluster. And then from an admission controller perspective, one of the other unique things that is available also is the validating admission webhooks. And this is where you can go out and, again, manage these admission controllers as code to call out to any external service. So this is where you can call back to your CI pipeline, say, has this image been scanned? What were the scan results? If this image wasn't scanned, I don't want to allow it to run. And so you can bake in a lot of these controls before ever even deploying. From a resource management perspective, the one kind of attack that we've seen pretty common from a Kubernetes perspective is cryptojacking. So people will leave their dashboards exposed, someone gets access to Kubernetes API, you spin up a bunch of pods, you start mining Bitcoin, and what you're going to want to have out of the box is setting these resource limits for your containers so that they're not going and being used for resource abuse on your infrastructure. This is one of the other things that's checked as part of the CIS benchmarks so that you can be notified if you're running any active images without memory limits or things like that applied. And then Kubernetes network policies, one of the things I learned the other day is these have actually been certified as PCI compliant. So even though you could have a workload on one node that's in scope of PCI and then the same workload on that same node that is out of scope of PCI, network policies serve as enough of a logical separation between those applications. So from a resource perspective, you can really start to schedule a bunch of applications on the same infrastructure, and then those network policies will allow you to segment that out however you want. So from a runtime security monitoring perspective, it's going to be the same type of things where you're looking for privilege escalation. If your container that was having inbound connections suddenly spawns an outbound connection. But what you really need to look for here is just an indicator of compromise rather than trying to focus on locking down everything from an application perspective. So this is where being really event-driven and looking at one of these indicators of compromise that could be tied to many multi-step attacks, and then auditing those and having that visibility over time is really important. From locking down those running images, you can use something like seccomp. There's a default Docker seccomp profile, and this is just going to really limit and sandbox that system call interface that image has access to. And one of the other approaches, and this is something that Sysdig has developed from an open source perspective, is Sysdig Falco. So this is an open source behavioral activity monitor where we can basically look at any of the system calls to see anything that's happening inside a container, on the host, any inter-process communication. And then you can use all the different Kubernetes labels, orchestrator labels, whatever you're using from a container labeling perspective to then scope policies. So how this works from an instrumentation perspective and why this is a little different is there's a lot of other security approaches where you might do something like an LD preload where you're actually injecting something into a container. Highly recommend avoiding that at all costs because you're going in and adding a dependency and losing trust as soon as you deploy that container. And with more of a modern eBPF-based approach, you can start to see all this syscall activity and see if there's an unexpected write, if there's any user that is exec into a container, and then from an instrumentation perspective, you get all that visibility. So some of the things that you can detect here are like if a user spawns a shell in a container, one of the things that you can see often is container breakout. So if a container tries to change its own namespace, if someone's modified a binary directory, those are all the type of things that are actually shown from a system call perspective. So kind of a real example of this is when a process is started, that's really the only time that it would need to access secrets. So if you have a process that's been running for a longer period of time in your infrastructure, and then it starts to try to access Etsy secrets, then that's something where you'd want to flag an event or potentially take an action like killing the container, restarting the pod, and things like that. One of the other attack vectors that we've seen that's really common in containers is you need containers to build containers, and these containers need privilege. So how do you lock down this infrastructure? And this is where you're going to want to look for any container breakout, if someone's changing that namespace, and then really thinking of your CI/CD pipeline as something you need to lock down as well. And then the last phase of this container lifecycle is incident response. So the example that I like to give here is, imagine my laptop is compromised, and before someone from our security team comes, I just decide to throw that laptop out the window. That's basically what Kubernetes is doing with your containers. So if anything happens to a container, by the time some human can actually go in and try and do any forensics or any investigation, that container is completely gone. And so you need to have preemptive data collection and methods to actually be able to see what happened before, during, and after any incident. So kind of the what, the where, the who, and everything else that happened in production. So how we did stuff like this in the past is with tools like Wireshark, where you would go and get a TCP dump, you'd feed that in. And now with containers, you're going to do this through tools like eBPF, or taking open source tools like Sysdig to write all that system call information to an SCAP file that then you can open up for that forensic analysis. So this is where, tying back into Falco, around any event that occurs in your infrastructure, you can flush those system calls that were put into a ring buffer, so you can see all the system events before, during, and after anything that happened in your infrastructure, so you have that full forensics and audit trail of everything that happened. And one of the things that kind of you hear a lot is like system calls, no one understands them, it's way too deep. But there's a lot of stuff that gives you really deep insight into what's actually happening in your infrastructure. So clone will give you insight into process creation. We've seen users go in and just send in an event for every exec VE command, so you can see everything a user's doing. You can also see like TCP connections with connect system calls, and all of that type of stuff is really the new interface for doing troubleshooting and forensics in containers. Because containers don't have a span port or something like that where you could really sit and listen to everything. And a container span port is the kernel. So that's really the source of truth for what's happening in your infrastructure. And one of the things that you can look at here is Sysdig Inspect, and this is something where I'll hop into a little bit of a live demo so we can see what a typical forensics and audit workflow looks like in the container world. All right, so here we've triggered an event for a user spawning a shell in a container. This is something that really should never happen in your infrastructure at all, because once you have a user doing something in a container, they can break out really easily. And this, on the flip side, like every developer will kubeexec or docker exec into a container to troubleshoot some issue. And you really should be just locking down those hosts so users can't do that. OK, someone spawned a shell in a container. What's the first type of thing that we're going to want to do? And we'll want to see the different commands that were executed for that event. So let's hop into one of these events here and drill out to see the different commands that were executed in my infrastructure. And had a little bit of an issue with the demo environment. So let's open up that system call capture with Sysdig Inspect. So what I can see here is the full system call interface for every single thing that happened before, during, and after that event. And this is the same type of data that you'd want to see with a PCAP file, but instead of those network packets, it's all the system calls. So at that point in time, I can look at when that event occurred, see the 10 seconds before, the 25 seconds after, start to overlay file activity, network activity, different executed commands to spot trends. And then what you can start to do is go in and isolate just the point in time that's relevant to your investigation. So now that we've seen that user went in and executed something in a container, let's look at what they actually did. So user spawned a shell, curled down some package, untarred it, and then deleted their bash history. So this is something where I'm definitely going to want to jump in, go a little bit further. And what we can do now is double-click on this tar process. And then if you switch to this files view, now I can see every single file that was written inside the container at that point in time. The thing to remember here is, like, if Kubernetes has killed your container, all that file system information is completely gone. And then from a system call perspective, you can actually go a little bit deeper here and see, OK, for the given files that were written inside that container, what were the contents that were actually written as well. So I can look at this from a printable view, see the contents of this README. And then if you wanted to just look at this from a raw perspective, you can go in, see all the different system events that were written to that specific file at that point in time inside the container. So from a takeaway perspective here, really implementing container security or anything from just a container perspective, you're going to live or die based on the processes that your organization puts into place. So by baking security into the development lifecycle, by being really diligent about the labels that you use, and then by just using the built-in stuff that both Docker and Kubernetes provide, are the things that you just need to do to implement security in your infrastructure. So that's it for what I had for you guys today. Thanks, everyone, for attending and sticking around. And I'd like to open it up for questions if anyone has them. No. Yeah. For users to troubleshoot containers remotely? Yeah, so this is something where you're going to have to rely a lot on the different monitoring tooling that you put into place. So if you have something like Prometheus and different open source options where you can limit the user access, but you have to be kind of diligent about your instrumentation and everything that you've done pre-production to troubleshoot those issues. So that's something where, from an instrumentation perspective, you got to bake that in. Yeah, so when you're going and like writing to a capture file and things like that, so you can choose to send those capture files to an S3 bucket or some other storage point and then encrypt it there. So like anything where you're going and doing some type of dump of system activity, wherever you do that long-term storage, you're going to want to have encryption, access controls, and all that type of stuff for these capture files. So this is something where it's really just a text file, and it's the same file format as PCAP. So wherever you store that, it's up to the user to implement those controls. Cool. Well, thanks, everyone. And I'll be out in the hall for questions and stuff after the session.